Good day. In this program, we are going to start a long-term discussion about artificial intelligence and custom architecture and how to put it together. In my case specifically, this is a Kotlin multi-platform plus some amount very unusual frameworks. So this is the pretty much start. I will be doing it little by little, chunk by chunk, recording small parts after another ones and combining all the pieces together. For the beginning, let me just iterate a little bit about my current setup, how I'm going to make these presentations, and how it's technically organized. You can notice I have lavalier microphone, which I bought for the only one reason, because it has mini jack and it's pretty much a good quality microphone. But the problem with it, that the impedance of input and output impedance of microphone and my audio card, they are different, and because of that, the microphone produces some amount of noise. And the first step I'm going to show right now is how to handle this and at the manageable level without getting into necessity to buy some additional tools and devices. So let me put it here. This is, I just fresh installed ABS, never had any experience with it before, so we are fresh new. We use absolutely default setups for channels, and all what I actually did, I went to filters. Let me put a little bit higher. No, it's not here. Yeah, it goes here. You will see. We are going to filters, and we are selecting the first one, limiter, which helps us to avoid some clipping. The second one, noise reductions, which does its job well with this preset, and I never tried another one. Small compressor with default values, which I consider the most helpful in our life circumstances, and I just put some little bit equalization for high frequencies. Let's check just a small sound check for the case, just demonstrate how it applies changes. So I'm commenting everything off, and you right now see the naked signal which comes directly to my audio card. Limiter doesn't help at this moment, and the signal is being processed the first, like from top to bottom. Noise suppression, we are just making this thing, and it start doing its job. After that, we can apply compressor, and you see there is no big difference. But if I would be talking quietly, you can notice that there are no specific losses. And equalization at the end is just to compensate the losses we have with high frequencies, because lavalier microphone has some weather protection. So that's pretty much it about our audio setup. And let us move it here. Now let's talk about video. Video with ABS on a Linux LTS 24 under Wayland is difficult to manage during recording sessions. The problem is that we cannot install extension which allows us to handle hotkeys globally. That means that every start, every finish, every scene change required focus into the ABS application. In the cases when we are just starting and stopping, it's pretty much okay to click back and forth. But I cannot imagine myself to switching in between scenes just in order to have this video of myself during presentations, because the application has complex user interface, so we constantly need to put some stuff like here. So whenever we need to switch anything in our UI and in our conversation. Kotlin code, it's maybe a couple of hours of effort plus a custom component which allows us to do this thing. And the very first moment which can be helpful to understand what the capacities of artificial intelligence actually are, you can try many models, whatever you would like to. Ask this if you are doing Kotlin code. Ask it first to make this component via managing X and Y positions. And very probably you will get pretty much quickly a good result. But if you would ask how to change paddings in order to achieve the same result, and here you will get a lot of very difficult conversations which will be showing the pattern. The pattern is because training data mostly contains the straightforward way of solving this particular task, you will be very probably getting the right result through X and Y's changes, the position on the top, on the left. But paddings, they are a little bit different, and you will see how all the models are struggle with that. So that approximately it for this small block. That previous example leads us to the topic of custom architecture. Custom approach aims to solve the problem which is very difficult to verbalize and even more difficult to find a balanced solution for that. And almost in any industry we have those, we can call it like elephants in the room, topics which are mostly cannot be addressed in current commercial development for the reason that we just don't have a time to dig into that. Some of custom frameworks give to teams very fast positive results. Some of them require years of investigation, years of verbalizing the approach which might be the best fit for that. So we always will be having like teeny tiny rest of development community which is interested in solving that. So I'm one of them. Now let's take a look at the application I'm currently working on, and which will be the topic of our programs during some amount of months. This app allows us to manage jobs and tasks. So what is job and what is task? From my perspective, the task is something which I can do immediately without involving any additional changes. If we are talking about agents, we understand that task for the agent will be very, very small. I can think that maybe 200 lines of code is what is probably average high quality LLM is capable of producing. But even for 200 lines, we will have approximately maybe 3 errors. Sometimes yes, sometimes not. Like, so that's kind of the idea of the separation. So if I'm doing all the tasks just by myself, I can imagine bigger blocks and to work with bigger blocks. When the task will be addressed for the agent, we need some mechanics which allows us to split the job apart and to say, for example, how many jobs we need to create, how many iteration in creating job tree we should have. This is the right part, which is pretty much, and that's kind of how actually we work with the code and with planning and so forth. That's how it used to be at tickets in Jira. Right now, tickets in Jira looks like jobs, which include a lot of moments to consider. Jobs includes sub-jobs. It becomes a tree which requires attention for each particular moment and solving this stuff independently on other jobs. So that's part is like my user interface. I can type prompt, I can type prompt for the job, I can manage it, and somewhere in between, inside of all this thing, we have those one guys. Let me pull it. I use ASCII art. Yes, right now it becomes much better. Inside of the app, we use a Python project. We exercise a lot of shell scripts, and we can formalize a little bit more using these diagrams. We will all of them, they are clickable, they have some user interface as well, but the main idea is whenever I have a problem to solve anything using my user interface, and I'm actually complaining upon what AI does, I should definitely have a place where I can adjust, where I can complain and make some changes into the system. So that's approximately the basic idea of the part which is already implemented. Now let's discuss a bit usability. So when we're looking at this diagram, we understand that each word, each term here has a real implication, has a real implementation somewhere in the code base. And it could be cool just to give us some links and to make this diagram clickable. If you can see, I can switch in between throwing click input into the new Vim or Android Studio, which I am mostly working with, but we will use new Vim just because it's small, it's easy to put and observe. So we wanted to make a click and see the result. We are making a click and we see the result. That becomes the most critical part in order to maintaining the system, which is complex, big, has a lot of moments to consider. Mostly they are prompts. You can see the difference in between red items and green items is that green items, they are mostly LLM based steps. And as you can see in the code, every LLM step we use, it has a RAG format and we have a scenarios. What does it mean? We will discuss. This is a very big and complex topic here. But this project utilize RAGs precisely in each place. We are separating RAG input and managing it precisely for each particular place of our pipelines. So this is kind of clickability on the base of diagrams. Let us close this thing and let's take a look how implemented. That part on the left bottom corner should be removed next time. You can see we have automatically generated links, and right now, in order to make it clickable in new Vim, we need to, I forget where we got it. Give me a moment. That was a very good catch, because I suddenly realized that I forget to implement a global switch for editors in order to make our links manageable. So let us create a task which kind of will be helping us with that. So let's go to current priorities. And among all the completed tasks, the current task regarding to the AI future application, that's approximately the best we can do for now. So we can type IS bar. And right now what we wanted to say where to store it. So we can click copy path reference, copy file name, and file name will be enough in our application in order to get a precise link toward the part which actually we wanted to address. Let's say the link will be bottom bar with, yeah. So we've got the link, we put it into the, yep, that might be misleading, but at least, yeah, at least this way it will be working. And we are clicking via KT, and we are adding the new task. As you can see, it automatically parses names into possible candidates for clicking. So whenever we are clicking right now at AI scope view model or AI scope integration, it will be opening currently Android Studio. You can see it jumps, but the Android Studio screen is very big, so I will make this presentation a little bit later. That's why I wanted NeoVim to be there. So that's approximately how this task actually might be observed. You can see when we just created this task, it appeared asterisk, which means that we have some task to solve. We can put a status and to say this is a task in progress, and we will see that the job we will get a red asterisk. So tomorrow when I'm going to wake up, I will open the job tree and take a look at red dots and figure out what actually task currently I wanted to start working on. That's pretty much it. Simple and easy. Whenever I'll click the next time at the status will be completed. And when the status is completed, it automatically puts commit hash. We can put URL. We can put URL even right now. Let me just make it this way. I just copied any link. And right now this link becomes clickable. It will be opening the browser page and so forth. But domain is just a short way. We don't want to have a lot of mess in our UI. So that's how usability allows us to manage complexity and to save mental energy, just in order to keep maintaining priorities. What needs to be addressed today, what needs to be addressed right now. That's kind of the idea. So for developer perspective, if you are thinking of that, okay, I can do it with purely with LLMs, or I wanted to implement some tasks manually or partially with charts, you can make a choice. And that's exactly what the system tries to address. A developer needs to have a capacity to make a choice. A developer not only needs to be in the loop, because saying like developer in the loop, it says nothing. I wanted to have a full control upon everything, whatever I'm doing. Why? This is topic for the next video. This is a big thing to discuss. why do we need a full control if our architecture is custom? Why do we need a full control if we are trying to dissect the job tree, create a possible way of solving unsolvable tasks, and be productive? Be productive.